Okay, so we're doing 15.1 part 1. We're splitting 15.1 into 2 sections. And this is all about integer exponents. So today we're just going to learn about the properties. So just what are they? How do I use them? So use the properties of integer exponents. I apologize now for all the key terms. So pause, write them down, and then maybe listen. So the product of powers is where we have, if we have the same base, we're going to just add the exponents and keep the base. And I realize I didn't even put the word base in here. The base is that number that's being multiplied over and over again. So 2 squared, the base is 2. That wasn't a very good example. 10 squared, the base is 10. It's the bigger of the 2. So for example, this would look like we would go like a squared plus, not plus, they're going to be times a product, right? Product. To the 5th, we would do a, and then we'd go 2 plus 5. Okay, that's what it means. And so we would get a to the 7th. Those were the same thing. Product being that they're multiplied together. So quotient of powers means that they're being divided. They're going to have the same base. You're going to subtract the exponents and keep the base. So for this one, it's like a to the 5th over, let's say, a to the 3rd. See how they have the same base? It's a to the 5th minus 3, and we would get a squared. So make sure you write these examples down. I think it'll really help. Okay, so power of a power is where we have an exponent raised to another exponent. Power of a power. Okay, so it's like a double exponent. So we multiply the exponents this time, and we keep those bases. So it would look like this. A to the 3rd, and then there's 1, and then we go like this, you know, the 4th. So it'd be a to the 3rd times 4 equals a to the 12th. So we multiply them there. All right. I know this is a lot. Product of a power. So we apply the exponent to all of the bases in the parentheses. So we have a product in here. Maybe we have A, B. They're being multiplied, right? Product. And they're being raised to the power of 2. What it's saying is everything inside the parentheses has to be applied by that exponent. So it would be raise A to the 2nd, and then B to the 2nd like this. So there's a product happening, a multiplication is happening, and they are then being raised to a power. So we apply it all. All right, a negative exponent is probably the hardest one of all of them. It's where you take the reciprocal, so a flipped over version, right? Remember when we divided fractions, we have to take the reciprocal of the second one. It's where you flip it over, of the base, and apply the exponent to the base. So I'll give you an example. So let's say we have a to the negative 3rd. This does not mean my answer is negative. That's not what that means. The negative just means take the reciprocal. Okay, that negative is telling me to take the reciprocal. So it would look like this, right? There's a 1 underneath here. I flip that fraction over and apply it back onto that base. And now if you notice, the negative's gone. Okay, we'll practice this one more because I know it's the hardest one. All right, 0 exponent. This one you need to add. So you add the above key term. 0's exponents is that they all result in 0 unless the base is, or they all result in 1 unless, add an S, the base is 0. So what they're meaning is if I go a to the 0 power like this, it automatically just equals 1. The only time that doesn't happen is if it's 0. So if a is 0, then it is not 1, it's 0. So if it's like this, it just equals 0, because, you know, everything with 0 is just 0. So, all right, I know that was a lot. So let's go practice that. See, lots of examples. So this first one, this is our product of powers, because see, I'm doing a product and I have powers, they have the same base. So we take our base and then we add these exponents. Look at it, it's almost exactly the same. And we go 5 to the 7th power. No, you do not need to multiply 5 to the 7th, you leave it like that. Now, the reason this works, 5 to the 2nd is 5 times 5. Then we're timesing it by 5 to the 5th. See? 1, 2, 1, 2, 3, 4, 5. Now look. 1, 2, 3, 4, 5, 6, 7. That's why it's 5 to the 7th. That right there is why. That's why we can do what I just did. So here we have a quotient. The rule just said that I can take 6 to the 8th minus that 3, and I would get 6 to the 5th. Again, you do not need to go and figure out what 6 to the 5th power is. You could just leave it like that. Okay? Now, why does that work? Well, again, if I spread this out, 1, 2, 3, 4, 5, 6, 7, 8, and I did it under here, 1, 2, 3, I actually can cancel matching ones out, and then I'm left with 5. Right? 6 divided by 6 is 1, gone. 6 divided by 6 is 1, gone. 6 divided by 6 is 1, gone. And once I have those 3 from the bottom gone, I have 5 left still in my numerator, and so that's why I just have 6 to the 5th. All right, 7 raised to the 2nd power, but then raised to the 4th power. So this is power to a power. So we go 7 to the 2nd power times 4, and we get 7 to the 8th power. Why does this work? Well, first I have 7 to the 2nd power. But then they tell me to do that 4 times. And if we then combine these, I have 8 of them. That's why that works. Take 7 to the 2nd power, and then do that 4 times. That's what that problem is saying. And so you can see now I have 8 of them. All right, negative exponent. This negative just means reciprocal. Okay, so just like we can put all numbers over 1, I'm going to flip this over, reciprocal, and then just reapply the positive exponent back onto that base. Now this one we could go find that, right? We do know that. And I don't have the pretty mathematical version to show you why this works, but I just need you to trust me. Because it's too difficult to explain in simple terms. So just trust me, negative just means take the reciprocal. All right, this is our powers of a product, right? We have a product being raised to a power. So it said that we have to apply our exponent to everything inside of it. So 5 to the 3rd times 6 to the 3rd. So just like I've explained most of these, I'm going to explain this one too. So what this is saying is take 5 times 6 and do it 3 times. Just like over here, it's very similar. Take 7 squared and do it 4 times. Take 5 times 6 3 times. And now you can see I have 3 5s and 3 6s, and that's why we can clean it up like this. Okay, this one is similar actually to kind of like this one, but then it also combines here. So remember, this just means reciprocal. So I'm going to flip this over first. 3 over 2. And then we're going to put the 3 back on. We actually then are going to very similar apply this rule over here. I didn't mean to draw that line. And I'm going to make it 3 to the 3rd over 2 to the 3rd. Okay, that was a really bad 3, but there's a 3 right there. So negative told me to flip it over. Then I applied my 3rd here, and then I applied that onto those 2. Clean it up even more. All right, so the last one is similar to the first one. We've got b to the 4th, b to the 7th times b to the 1st. Anytime you have something that doesn't have an exponent on it, it's always 1. If there's 1 there, there's an exponent of 1. So just like if it was just the number 2, it would be 2 to the 1st power. So all the numbers you've always known, 1, 2, 3, 4, 5, 6, 7, so on, have always had an exponent. We don't need to write it, but it's always been 1. So here's what I want you to do. I want you to pause and see if you can solve and simplify that using one of our exponent rules. Which exponent rule would you use? Pause. Try it. So this, you should have applied our very first rule. These are all the same bases, b, b, b. So we're going to go big B, and then we're going to go 4 plus 7 plus 1. And you should have gotten b, 7, 9, 10, 11, 12. Okay, and that's just if I wrote all these out, right? B times B times B times B. Then here's my 7. And then here's my 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why it works. All right, here's some more. A little more complicated, a little more pieces, but all we're going to do is kind of combine a couple together, okay? So this first one is quotient of powers, but the only ones that have the same base are these two. So we're going to actually leave that 9 completely alone, and we're going to just leave it in the numerator, leave it until the end. So we're going to apply the rule here. We're going to go a to the 13th minus 3 and get a to the 10th. And so now positive 10, I'm just going to go 9 times a to the 10th. Done. Because the 9 was the only number, there was no 9 base anywhere else. I just don't do anything with it. I only apply the rules to a to the 10th. Okay. Or anyway. So this one, we can see we have k. Trying to box it together. No x, so that one's going to hang out by itself, but we actually are going to just divide here. So we actually have like 3. We're going to do 15 divided by negative 3. We're going to times it by k to the 7th over k to the 5th, and then we're going to times it by x to the 3rd. And we could, if we wanted to, write it in fraction form as well, x to the 3rd over 1, if you want to keep it all the same, because I can put anything over 1. So we can find all of these. What's 15 divided by negative 3? Well, 15 divided by 3 is 5, or yeah, 5, and then it's just an opposite sign, so it's negative. Here we're going to subtract. So k to the 5th, 7th, I lied, 7, minus 5, and we're going to get k to the 2nd. And then because there's nothing to do here, we're just going to write x to the 3rd. They're all different bases. So if you really want to clean it up, you can write it like this. Get rid of those multiplication symbols. Okay, last one. So just like when here we divided these coefficients, same thing here, we're going to actually multiply these. So it's going to look like this. 6 times 3, separated, and we're going to go times x to the 5th, x squared times x to the 5th. You put the similar things together. It's like combining like terms like from forever ago. So 6 times, oh, it's -3. Don't make me lose my negative. We're going to get -18 times, well, we have to go x to the 2nd plus 5, because that's my product of powers. We add them together. And we get -18 x to the 7th. So it's just going to be really memorizing the examples and memorizing these rules. When do I add? When do I subtract? When do I multiply? Okay, it's just practice, practice, practice. So the main thing to remember is to memorize the rules. Like that is 100% the main thing. Okay, so these are your 2 independent practice problems. Let's see how you can apply your power rules to get your answer to these. Excuse me. All right, until next time.